So shall we evaluate these two limits? Now, to evaluate these limits, we are actually going to apply the Hoptal'S law. Alright? The Hoptal'S law, which states that we have to differentiate both the numerator and the denominator once after replacing we are getting something like 0 over 0 or infinity over infinity. So if you replace dialect here, let's talk about number one. If you replace dialect here, right? Dialect replacing here, you discover that you are going to get 0 over 0 because sine 0 is just 0. And when you put here, this is 0. So this one is an indeterminate form. Or in other words, this is undefined. So we cannot evaluate this. So what we do, we apply Hoptal'S law. Hoptal'S law allows us that we do what? We differentiate the numerator, also the denominator. So here is what we are going to do. So we are going to have the limiting as x approaches 0. So we're going to find the derivative of sine x, also the derivative of x. Are we there? And this will give us the limit as x approaches 0. For which one? What's the derivative of sine x? It's actually cos x. Derivative of x is just 1. Now we replace here. Where there is x, you put 0, and this will give us 1. This is a special identity which you need to know. It's a special limit. Alright, so the limit of sine x over x as x approaches 0 is actually equal to 1. Number 2, if we try to replace infinity here, we end up getting infinity over infinity. Why? Because e to the power infinity over infinity squared is just infinity over infinity. So this is also indeterminate form. So what we do, because of this nature of this guy here, which is giving us infinity over infinity, we apply Hoptal'S law. So it will require us to differentiate the numerator and the denominator. And what do we get? E to the power x, when you differentiate it, you're just getting the same. As x approaches infinity, you are still getting e to the power x. Here you get what? To x. If I replace here, I'm still getting infinity over infinity. I still have to work this guy out. Okay, we differentiate again. So we are going to have the limiting of what? E to the power x, we differentiate this guy, over 2x, we differentiate this guy as x approaches what? Infinity. So what we get? We end up getting the limit of e to the power x over 2 as x approaches what? Infinity. Can we replace now here? Yes. If we replace infinity, we are getting infinity over 2. What is 2 into infinity? It's just infinity. Because infinity, it's a bigger number. Okay? Therefore, we can say the limit as x approaches infinity for which one? For e to the power x over x squared is just equal to infinity. You're welcome. Cheers.